Let's figure out how to take degrees of latitude and convert that to a real world distance. Here's what we're looking at. Let's say that this is a little drawing of our globe. We have our line going around here. This is going to be our equator, so that's going to be at 0 degrees. And we're going to have two different locations. Maybe one location is going to be way up here, and the other location is here, and we want to figure out the distance between those two spots. Maybe it's going to be someplace that's here in the northern hemisphere compared to someone that's there in the southern hemisphere. Now we know that at the equator we start counting. We can go all the way up to the North Pole, and that North Pole will be at 90 degrees north, or we can come south, go all the way down to the South Pole, and that will be at 90 degrees south. Now, how do we do this? Well, it all depends. As we're looking at the distance that we're going to be following, if we're wanting real world distances, there are some standards that we're going to be using. For every 1 degree of latitude, remember that's going to be going north from the equator or south from the equator. 1 degree of latitude is going to be equal to 69 miles or 111 kilometers. Okay. So if we can figure out how many degrees of latitude, we just take that value, multiply it times 69 miles, and we multiply it times 111 kilometers to get our distance. Now, how do we do that? Well, that depends on whether our places are in the northern hemisphere or the southern hemisphere. Okay. Let's say that we're looking at two different locations. Maybe we're going to be coming up here to Sacramento, and so we'll come up here to about 38.5 degrees north, and we want to know what the difference is compared to somewhere else that's maybe down here, maybe at 7 degrees north. Right? Because both of these locations are in the same hemisphere, we're going to take these two values and we subtract them from each other. Okay? We're always going to be a positive number. Here's basically what I am doing as I'm looking at this. I'm going to be taking 0 up to 38.5, but then I'm going to be subtracting 7. Because the real distance that I really care about here is the angular distance that we have going in right here. So I get 38.5. I subtract 7. That will give me 31.5. And then that's going to tell me how many degrees difference it is. I simply take that 31.5 times 69 miles, and I take 31.5 times 111 kilometers. Now, other times what we'll find is that our location is going to be in different hemispheres. So I'm going to draw this guy out again. We have our Earth. I'm going to be putting in my equator right there at 0 degrees. Maybe we're going to be looking at someplace up here in Sacramento that is at 38.5 degrees north. However, this other location is going to be down here at, let's say, 14 degrees south. In this case, it's kind of like a number line, but what I need to do is I need to figure out how far it is from 0 up to there, and then from 0 down to there. When we are in different hemispheres, we add those values. So I'm going to take 38.5 plus 14 is 0.0. That gives me 0.5, and we'll take 12 and carry that with 52.5 degrees. To figure out how far that is in real world distance, I take 52.5 times 69 miles and 52.5 times 111 kilometers. If they are in the same hemisphere, then we subtract them. Always take the big one, subtract the small number. And when they are in different hemispheres, we add them. Going north and going south, we need to add both of those values.